The .NET Conf team is bringing to you a .NET Conf Focus event on January 14th, 2020 that's all about building web apps with Blazor. This will be a free, one-day live stream event that features speakers from the community and also the .NET product teams. Make sure to tune in to focus.netconf.net and come see what all of the excitement is about. Ask questions live and get some deep training on how to build beautiful, interactive, and powerful web UI with Blazor.
In this episode of the On.NET Show, we're going to have yet another video where we're going to talk about Azure Service Bus. And this time, we're going to dive really deep into some really advanced features that may be great for some of our enterprise customers. Hey everyone, welcome to another episode of the On.NET Show. And today, we're going to continue our conversation about Azure Service Bus. And we're going to dive deeper into some of the more advanced features that are available on the service. So, Ashish, tell me, what are we going to talk about next?
Perfect. So, yeah, let's talk about all the enterprise and advanced features that Service Bus offers. And let's start with something that a lot of customers have been asking for, and we've built quite some time back, actually.
Okay.
So, lots of customers have asked for, hey, can we do FIFO, first in, first out with Service Bus?
Mm-hmm.
And we always say, hey, Service Bus is ordered on receipt by default, but we don't make ordering guarantees unless you use sessions.
Okay.
Right? Yeah. So we do have that functionality built in, and what that allows you to do is to group these messages that may be related to each other by setting a session ID on them.
Okay.
And as long as they have the same session ID, they'll be grouped together, and then you can lock the session itself, right?
Okay.
So the way it works is let's look at this. So let's say the sender sends a bunch of messages.
Yep.
Now the blue ones and the light green ones are different sessions. They have different session IDs.
Sure.
So that's the S1 and the S2, right? And the sender has set these on the as a property on the message.
Yep.
What it's actually doing on the back end, it's actually creating two virtual queues, right?
Okay.
One with session ID equal to 1, and the other one with session ID equal to 2.
Yep.
Right? And now when the receiver comes in, the receiver can no longer say, I want to peak lock on a message. It has to say, or message handler, it has to say, I want to peak lock on the session itself.
Yeah.
Which means the entire session is now blocked by the receiver.
Yeah.
And now, since we have blocked it and it's in order, the receiver can start processing these messages in order, one after the other.
Sure.
So that's pretty straightforward. It allows them, the session acts as a virtual queue on top of the queue itself. And as long as you lock the entire session, that session is not visible to anybody else.
Got it. So it's locked to a particular receiver.
Yes.
Right. And it's also ordered, right? So the receiver should know, hey, I'm expecting like this sequential set of messages to come in.
That is correct. Yeah.
Got it.
So sessions can be long running. It's not like there's a start session and a stop session on the sender side. You just set the message ID or the session ID with what you want the session to be, and that just keeps your session running.
Got it.
So let's say in the future, the receiver, the first receiver, the one that's the dark blue or the gray, wants to hold on to that session. They can potentially hold on to that session ID and say, yeah, if this, I'm going to lock the session and only process it if the session ID is this.
Okay.
So you can ensure that the same session goes to the same receiver, or at any point in time, a single session is processed by a single receiver.
Right. So it's almost like, so for me, I'm very familiar with the web world. In the web world, that sounds like what we call sticky sessions. Right, like when we hit a load balancer, right, and we just want to make sure that we hit the same server every time whenever we send our messages.
That is correct.
It's kind of similar to that, right?
That
like
is correct.
We're hitting the same receiver
Right.
on the service bus side, once we lock that particular session.
That is correct. Yep.
Got it.
So a very quick code sample. It's pretty straightforward. All you do over here is set the session ID. So I just created 2 session IDs at random, and I just plug those into the messages at random as well. And then on the receiver side, we saw the receive or register message handler earlier.
Yeah.
Now we have the register session handler instead.
Got it.
And the way it works now is that you're locking the entire thing and then processing the message one after the other.
Got it.
But it's still a session lock, not a message lock.
So then the receiver side needs to know that it's particularly looking for sessions.
That is right. Yep.
Got it. Okay.
And actually, it's more it's more management oriented operation than that. When you define a queue or a subscription, you have to essentially check a box that says enable sessions.
Okay. Got it.
So once you have sessions enabled, you cannot just send regular messages onto it. It has to be sessions only.
For that particular queue that you're sending.
Right.
Got it. Okay.
I mean, you could in theory have a single session or a session with a single message to mimic the same behavior. But remember, sessions are slightly more computationally intensive.
Yeah.
Because you need to keep them grouped together and make sure they're in order. So make sure you only use it when you want to group these messages together and lock it at on a per session level.
Got it. That makes sense.
Yeah. So let's move along and let's look at auto forwarding. Right now, you could forward messages from one queue to another queue or another topic by writing an application that reads from one end and then pushes it out to the other. But we want to make that easier for you. So you can set up auto forwarding from a queue to a topic or a queue to another queue from within the Service Bus broker itself.
Yeah.
And the way it works is that multiple patterns can leverage this. Let's say your sender queue is acting as a send buffer, and the receiver queue is acting as a receive buffer, and you want to decouple it even further.
Yeah.
Then you could have a send queue that automatically forwards to the receive queue. So you don't have to worry about essentially having the queue depth increase on the send side just because the receivers are slowing down.
Got it.
Right. You could also scale out individual topics. So currently we have a limit of 2,000 subscriptions per topic, but there might be cases if you need to fan out even further.
Yeah.
So then you could have your subscription forward to a topic and then fan out from there.
That's interesting. So now I think between that and our ability to specify rules, we have like a really interesting pipeline that we could create in terms of like how do we route messages and like where do they go?
That's exactly right. I mean, it even works with like different silos in the same org, wherein each has their own queue to read from, and you want to keep configuration kind of clean in that form.
Sure.
So you can have forwarding parts and set up pipelines like you mentioned.
Awesome. Nice.
So the way it works in this case is that you can, your sender sends to the queue as expected, and then the queue automatically forwards it in one shot.
Got it.
The queue1 in this case will not have any depth because it immediately forwards it.
Yeah, immediately sends. Yeah. So its sole purpose is just to like distribute messages to other folks.
That is right.
Got it.
Again, simple code sample over here. These are all management client operations. So you instantiate the management client, create the destination queue first because you need to have something to forward to.
Yeah.
So once the destination queue is created, then you can add the forward to destination in your source queue's description, and then go and create the source queue.
Okay. Now you're showing us these management samples inside of using .NET code right now, but could I also use something like the portal or the Azure CLI to specify these rules too?
Absolutely, yeah. So the same semantics work or the same workflow works over there as well. You first create the destination queue.
Yep.
Then you set up the source queue, and you can have a forward to parameter that you can set.
Yeah.
So that's all available as well. There's also ARM templates, any kind of PowerShell CLI.
There's tons of different options for us to create these things.
Yeah. So your DevOps pipeline will be very happy as well.
Nice. Okay.
Perfect.
All right. So what's the next one we got to talk about?
So next one is the scheduled messages. Now there are times where the sender wants to control the narrative of how the processing should happen and when it should happen.
Sure.
And that's when you can essentially schedule these messages.
Yep.
And what that means is that the sender simply says, hey, I'm sending this message to you now, but the receiver should only be able to see it after a point in time. It could be a specific date in the future, it could be 5 days or 5 minutes from now, etc. And that is something that the sender can control.
Yeah.
So the message is immediately accepted by Service Bus as expected. And then it'll only show up once to the receivers once that time has come.
Yeah, got it.
So it just stays hidden behind the scenes in the Service Bus program.
Right. And I think this is actually one of the features that I've used a fair amount.
Right.
Particularly like for demos or I think I created like a tweet scheduler, right? Because I'll do everything on Twitter. But like if I want to schedule a message, right? Like I'll just I'll pass it to the queue, I'll set a date, and then whenever that happens, like my Azure function kicks off and then it starts to do work, right?
Right.
And so I think that's a great way for us to like schedule things. And again, using the power of the cloud to like just power like whatever that workflow is.
Yeah, and it fits in with the goal of essentially simplifying your programming model to say, hey, my sender came back on, it's all good.
Yeah.
I'm gonna just send this message, and now it's a PaaS responsibility to worry about pushing it out there to the receivers at a certain point in time.
Right. Yeah. That's awesome.
So what if you want to control the narrative on the receiver side, right?
That's a good question.
Yeah. So that's a different feature as well. Now in this case, that's a deferred message, right?
Okay.
What happens in this case is that let's say your receiver decided to lock the message, and it starts processing it, but something is not ready yet. Let's say there's a reference data or database that you're looking at,
Sure.
and you're expecting the data to be there, but it's not there yet.
Mm-hmm.
And you want to get back to this message. It has to be you, but you want to get back to the message at some point in the future.
Right.
So we can say, you know what, let's have the receiver lock it, but at the same time, the receiver says, okay, I'm going to defer it so I can revisit it later. Now,
Okay.
how it does that is that the receiver gets the sequence number of the message and it holds on to it.
Okay.
And that is very important because if you lose the sequence number, you will lose the message, right?
Yeah.
But once you defer the message, you have to query the message using the sequence number.
Yeah.
So the way it works is, the sequence number is made available, and the receiver says receive with the sequence number, and that's when the message comes in.
Got it. So here's a question I have. So I have deferred this message. I have the sequence number. What happens if my receiver dies?
So at that point, you will have to persist the sequence number on your end.
Put it in a database or
Right.
Azure storage or
And
a
that's
thing, something.
Yeah, and that's exactly the pattern that most customers use because they will just plug it into a database and have retrieve that when needed.
Got it. Okay.
It's a well managed workflow. So it's something you code for, not a byproduct of a feature that we provide.
Got it. Well, that kind of makes sense,
Yeah.
right? Because you might want to, depending on how your receivers scale up or scale out,
Right.
You might want to have a little bit more control over like who is going to be the person that is going to resume this activity.
That is correct. And it could be that this message is related to something that came in earlier, or or if, just in case you don't use sessions, or there's some sort of idempotency in your receiver side. At that point, yes, you could leverage it from using deferred messages to say, yeah, it'll be me who will process this message, but I will do it when the time is right.
Got it. And so here's another question about that too. So let's say I was not proactive and I didn't store that message. I didn't store that sequence number for the message.
Right.
And my receiver died. Does that deferred message just stay there? Or does it expire after a period of time? Like what happens?
Yeah, so it'll stay there as long as you query the message with the receive sequence number and then go and complete the message. So it'll just stay there.
Okay.
Now, if you lose the sequence number, there is a message, that message is lost. It's not lost in the broker. It's lost because
From the receiver side, I can't go back and get it.
Yeah,
okay.
that's right.
So it's still there though, we're still holding on to it.
We're holding on to it. It's potentially inaccessible at this point.
Yeah.
So that's something, I think it would land up in the dead letter queue.
Eventually, yeah.
Yeah, but that is something that needs to be built into the workflow to say, I'm going to definitely persist the sequence number before deferring it.
Right.
And it's on the message property itself, so you can go ahead and do it.
Right. Because I know in the message properties, there's a time to live and
Right.
expiration times that we could specify too.
Mhm.
So I guess with a combination of those,
Right.
if it's, I don't know, maybe I say let it sit for 7 days or a month or whatever the case is. After that expiration time,
Right.
they'll just go in the dead letter queue.
That's right.
And then now we'll have some other process that'll look and be like, hey, what's going on here?
That's right. Yeah. So
Okay.
that's exactly what will happen. You can set the TTL. Once the TTL expires, we move to the dead letter queue.
Yeah.
The way it works with deferring is, I think it pauses the time at the time at the time of deferral.
Got it.
But you get into confusing space, so most folks will not use TTL and then use defer
Right.
on that end.
Got it. Okay, cool.
Yeah. So a quick look at the code. Fairly straightforward. You basically, in this case, I'm using a list to add the deferred sequence numbers when I defer the message. You can actually go ahead and store it in the database like we talked about earlier.
Yeah.
And then once you have stored it, you want to retrieve the message, you can go ahead and say receive deferred message async and then provide the sequence number.
Got it. Okay.
So you can do that.
Nice.
So moving along, we have the duplicate detection, and in this case, you've seen multiple. You may have browsed the website where you made a payment, then you said, "Hey, don't refresh the page because."
Right, or don't hit the submit button more than one time
yeah.
or something like that. Yeah.
So that's the best case, best example I can give of how we, how duplicate detection is set up.
Yeah.
And what we want to do over here is, let's say your sender sent a message and then failed before we sent the ACK back, right? And it got back up again and said, "Hey, I need to send this message again."
Yeah.
But now it's sending the message over, and it expects that the sender has no context into what happened before it crashed. So the idea is that what do I expect the service bus broker to do in this case?
Right.
So it's pretty straightforward. What we do is we allow you to put on the queue or the subscription a duplicate detection window. It could be up to 7 days.
Yeah.
What that means is that you send the message once, we'll ACK it back to you. If you did not receive the ACK, or you were not live when we send the ACK to you,
Yeah.
if you send it back again, we will give you the ACK back as you would expect if you come back from a failure.
Yeah.
But we will trash the copy of the message.
Okay.
So at that point, over that duplicate detection window, if you send the same message with the same message ID, we will make sure we only have one copy.
Got it.
And the way it works is, like I mentioned, you send the message with the message ID 1, we send the ACK back. Let's say the sender crashed at this point, gets back up, sends the second time. We'll send the ACK back again, but the message ID will go straight, the copy will go straight to the trash, so to speak. So we only have one copy within the duplicate detection window.
Right. So what could happen though is, because I've seen situations where people have recreated a message to be sent.
Right.
But the message ID is different, but the contents of the message might be the same.
Right.
In that scenario, duplicate detection doesn't come into play because of the fact that the IDs are different.
That's correct.
So it sounds like it's important that I should have some type of deterministic algorithm or something to either hold on to the message or regenerates like a known message ID.
Right.
So that when I recreate it and I resend it, now duplicate detection can do its job, right, and look at the right properties and figure it out.
That's exactly right. And because we store everything in the binary format, it's not really that straightforward to dedupe based on the message content.
Yeah.
Computationally and just in general as well. We rely on message ID, and that's exactly what we recommend you set in the deterministic fashion, like you mentioned. So
that sounds pretty fair.
Yeah,
that sounds pretty fair. Cool. Now we got some more cool features to talk about, right?
We do, yeah. So jumping back into our enterprise mindset, right? What do enterprises need? They need something that's highly available. It can recover from disasters. Yeah. And that's exactly what we want to provide as a service over all the other brokers that are out there. Yep. And build in this cloud native environment.
Sure.
Right.
Okay.
So a lot of folks may be familiar with the concept of Azure availability zones. Now this is something we offer for Service Bus as well. And this is a premium only feature because of the architecture of Service Bus Premium. Sure. But the way it works is that on the premium end, whenever you send a message and we ACK it back to you, we're triple replicating by default. Yeah. Now, when you have AZs available, those 3 replicas live on 3 different data centers. Okay. Within the same region, so they are off, away by a few miles, but they're still different data centers. Sure. So it provides you fault tolerance within the same data center region. Right. And when I mean within the same data center region, let's say one data center had any kind of utility fault or a network wire was cut.
Something happened. There's a hurricane, tornado. Whatever.
Well, that's more of a region going down, but this is more localized. Right. But yeah, something to that effect, where one data center is affected. Then the other data centers can pick up the load. Yeah. Right. Okay. And all this happens. All the replication within the region is synchronous. So once we have that available, it's totally straightforward for you. Yeah. For your sender application, you don't have to worry about it. There's no additional latency involved with replicating it.
Got it.
But the way it works is, like I mentioned, we have 3 copies of Service Bus, 1 in each of these availability zones within the same region. 1 acts as a primary, the other 2 are secondary. Let's say if the primary goes down for whatever reason, then we will promote one of the other secondary copies to primary.
Got it.
Right, and this will happen, absolutely abstracted away from the sender application. So you see no issues with your, with your applications disconnecting or reconnecting or any of that sort. Just works as is. You just get the extra availability. Got it. And the fault tolerance within the same region.
Got it. Okay. Cool.
So let's say, we already spoke of fault tolerance within the same region, but what if you need fault tolerance, across different data center regions, like your hurricane example, like you mentioned. Sure. So in that case, we have the geo disaster recovery. Now, what we currently provide is, DR with metadata copy, which provides you an RTO, right? Okay. So let's actually look at this, or look at the mechanics of this. What you do is you essentially go to 2 different regions and create 2 different premium namespaces. Yep. And then you pair them together. Okay. Now, once you pair them together, we will ensure that all of your metadata, so your queues, topics, subscriptions, rules, filters, etc., are always in sync. Got it. So, in that case, any of your, CRUD on your queues, topics, subscriptions will be synchronously copied over to your secondary as well. Got it. Okay. And what that means is, so this is, like I mentioned, providing an RTO, a recovery time objective. Okay. Let's say something goes wrong with the database, with the data center, region at the time. And it doesn't really have to be a hurricane. It is a manual failover. So you pick your definition of a disaster for your application.
Oh, really? Okay.
Yeah. So for you, it could be, hey, my application isn't live for 5 minutes, or I'm not able to connect the service bus for 5 minutes. It need not be an earthquake or a hurricane or something.
Right. I have the flexibility to define my own thresholds and limits and whatnot.
That's exactly it. So yeah, the thresholds, limits, you have the remote in your hand pretty much to say, yeah, I'm going to do a failover. I'm going to move from my primary to my secondary region.
Got it.
Now in that case, your data is not copied over. Well, like I mentioned, it's metadata only.
Yeah.
But your applications will not fail with a queue not found exception or a topic not found exception.
Yeah.
So they can pick up or they can start sending and receiving from that point forward. But the data is not copied over.
Right.
Now that doesn't mean that the data is lost, right?
Yeah.
Like I said, you pick your definition of a disaster. It need not be a pure earthquake or hurricane that has essentially going to destroy the disks.
Yeah.
That's the only case when you actually lose the data. So it's a fairly well controlled environment. Your data is committed, like I mentioned, triple replicated to each of these copies, and they're still accessible once the data center region is back online.
Got it.
But they're not copied over. So the reason we make sure it's persisted is that you can go back, still access that namespace like you would, and then drain out those queues, identify which ones are still valid or still needed for you.
Yeah.
And then you can go and start processing those messages.
Right.
Onto your secondary.
Onto my secondary.
Right.
That's awesome. Can you like what you said, like from a developer's perspective, like my code doesn't really need to change, right? Like
It
this
does
just kind of just works for me.
Right.
And I just have that reliability that, again, if something happens in this particular data center,
right.
My stuff is just available somewhere else and I could just keep doing my work.
That is correct. And the reason it works without any kind of code changes is because when you actually trigger off the failover, the connection string that you were using to point to primary will now automatically point to secondary.
Got it.
Right? And so you don't have to worry about any kind of code changes on your end. It just automatically works. The amount of time it takes is under 5 minutes because that's how long it takes to essentially flush out the DNS entries and make it point to secondary.
Got it.
But that's pretty much it.
Gotcha.
And obviously the expansion to this is full data copies. That's exactly what we're working towards.
Yeah.
And that's something we would like to provide the customers as well.
Cool.
To say, hey, it failed. Now I'm going to fail over. And now let me pick up from where I left off in terms of processing the same data so that you don't have to worry about draining and replaying it.
Got it. This is awesome, man.
Yeah.
Like I've been using Service Bus personally for like a couple of years, but like after these conversations we've had, like I feel like I've just learned so much more about the service and more of the things that we could provide. And I know there's tons more stuff that we haven't spoken about, like security, and we haven't gone into the depths and details of AMQP and like tons of other stuff that's under there. But I know we have docs.microsoft.com if folks want to dive in and like learn some more about that.
Absolutely.
And we can add those show notes as well.
Absolutely.
Are there any other resources that you and your team provide that we could send our viewers to just learn more about Service Bus, play around with code, or even just reach out to the team?
Sure. Yeah. So we do have our open source SDKs that are available for folks to open issues on, contribute to. We also have open source samples available, so they can have that on our Azure Service Bus repository.
Yep.
And they can engage with the dev team that actually builds the product. And yeah, apart from that, like you mentioned, the docs are out there. We talk about all of our cool stuff with security, with virtual network service endpoints, firewall filters. We have MSI in our back, so managed service identity and role-based access control, wherein you don't have to worry about connection strings anymore. You can just plug an app and tenant ID, and things just work as is. And you can set very granular scope in terms of, hey, I want this application to only write to this queue or only receive from this subscription.
Right.
And that flexibility is all built into the product as well. And then we keep, adding more and more features that we blog about, we tweet about. So
I can't keep up with y'all, man. There's so much stuff going on.
Yeah.
But hey, thank you again so much. I really appreciate you coming on the show and teaching us about Service Bus. And thank you all again for watching. I hope you enjoyed this. If you have any feedback or any comments, definitely leave a comment in the comment section below. Share the video with your friends and your coworkers. And I hope you enjoyed this episode of the On.net Show.